You gotta cite your source.
So I see what you're saying. So the only thing that's different is I'm gonna take from you, but I'm gonna tell you I'm taking.
All right, what's going on, guys? I'm Nate Williams. That's Brent Fisher. We're here for a flat Earth debate. So we're going to start off with our introduction and let each other know, what we believe and why we believe it. And from there, we're going to take it into asking each other questions so we can defend our positions on what we believe about the Earth being round or the Earth being flat. What sparked this thought about the Earth being flat?
Overall, I just think that speaking to a guy at the YMCA, older guy, he basically said to me, it's about 2.5 years ago, maybe 3. He said, I need you to tell me why the moon doesn't spin. And he just said it like randomly. And we usually talk about sports or whatever. So he said that and I was like, okay, I didn't even know it was a thing. I never thought about it. So as I did more and more research, I immediately had the knee-jerk reaction that the moon does spin. Did more and more research, found out that it doesn't, and that led me to where I am now. So, and that and a general distrust for the official story, usually from entities that have a monopoly on information, always lends me to try to do a little more research on what they told me and why.
So my first question I posed to you,
Okay.
who will be doing the line and why?
That is a big question. So I think overall, whoever gives us the official story, in this case it would have to be NASA, gives us the official story about how the Earth came to be, number one, where we are in the universe and how things work. The reason why I think they did that is to strip the power from human beings as individuals that understand their own potential and give us more of a group think type of thing. This is the reason why social media works, is the group think theory. So just to take it back a little bit, if we knew for a fact that the Earth was built, like handcrafted by a creator, and we were put here as individual souls in a vessel, then I think that our overall paradigm and axionomic ways of going about life would change completely as opposed to how we are today. It wouldn't be so much of a I'm going to follow the next person to beat the next person at what the next person is doing. It would be, I'm going to take whatever tools I was intrinsically born with to create the most masterful pieces of what I am, period, if that makes sense. So I think that's what it is. You kind of remove the divinity from the human experience. And I think that's why.
So it's a lot of, religious standpoint. Well, not religion as in like the whole structure of religion, but just the thought.
Right.
Of a higher power.
Right, the higher power piece. I'm not religious. Anybody that knows me knows I'm not religious. I don't even know where a church is. But I know that the human experience, things like if somebody gets hurt and I see it, I'll feel it. You know what I'm saying? Like somebody fall on the ground, like you have that intrinsic empathy and you're a shared collective consciousness. The source of that collective consciousness is what I believe to be whatever created us. Or it could be the actual consciousness of the creator, like flowing through us, whatever. But I don't understand it, so I'm not going to try to speak too much on it. But I know that if you take that from us, then we're constantly seeking an authority figure to help us move about this plane. And that's what I see with social media. That's what I see when you have little girls wanting to be like people who twerk on TV or YouTube. Instead of, what am I intrinsically? Like, do I like to play in trees? Do I like to run around in the grass? all right, so am I more a nature person? Do I want to create things out of nature and all that kind of stuff? So that's kind of where I was going with that. Like, I really think that it strips us away from our divinity as creative human beings.
But we knew the Greek philosophers believed the earth was round.
Gotcha.
So they did experiments based off of different observations to make, the theory that the earth is round.
Gotcha.
So my stance has kind of been, that theory has been long standing, right? And a theory is something that's been tested, tried, observed, and you can repeat it. So if that theory has been long standing, then the only thing NASA had to do was just go out to observe it.
Right.
So as part of the divinity, I think religion is like probably one of the biggest things going on in the world between like Christianity, Islam. Like, those are still huge thought processes that consume most of mankind.
Yeah.
So how would a round earth take away that divinity?
So they say that we're a speck of dust in the globe model, in the middle of a black vastness that came about from a huge bang, and we're just a collected bunch of materials that somehow got a spark, which will be consciousness, that they can't really explain. They just call it some kind of a spark that comes about this mass of just human flesh, and then we die. So that, I think, takes us away from, you were created from the thing that created everything to be the best version of yourself. And that's where I think the disconnect would be. And I want to keep it as simple as that, because I don't want to go too far into who's right, like Christianity, Taoism, Buddhism, whatever. I think people are here to be the best version of themselves, to take information, put it into their consciousness, and stream it to the cloud when they die. It's kind of what I'm looking at.
I get that.
So, man, I think that the globe prevents that because it cuts you off from the creator. It distances you. It doesn't completely cut you off, because even with the globe model, you do need something to make that thing all work. So
with the globe model, we still are the only humanoid species that exists, like, in the universe that we know it. So that would kind of make us special, right?
I think it would make us special in an egotistical type of way, not in anything provable. They talk about things like light years, how far light travels in a year, and I'm really not banking on something taking pictures from 900,000, 2 million miles away, when I can't get reception in a subway. You see what I'm saying? Like, I
hear what you're saying.
I'm trying to make this as practical as possible.
No, I understand what you're saying.
It's a stretch.
Yeah.
It's a stretch, because my equipment is not like NASA's. It's completely different. But we've never, as regular people, we've not experienced anything like that. So why can't we take pictures from the ground at night of a star? You know what I'm saying? Like, if you can get a regular person to do something like that, then I think it would give more credence to when the people who own the official story, the monopoly that has the monopoly over the information, gives you the information.
I guess there's a disconnect for me somewhere between them lying about what we can do on our own.
Right.
Not to the same level that they do it, but we can still see some of what they see.
Okay.
With our own instruments.
So I think, and I'm gonna just address this point, and I'm gonna ask you my question. I think that what we're seeing, that dark cloud is called the Great Rift. They call it the center of the universe. I don't really think that that's true.
Center of the Milky Way.
Center of the Milky Way. They call it the center of the Milky Way. I don't think that that's true. And the only reason I say that, and I don't have too much proof behind this, is because when I look through my telescope, when I look at a star, it doesn't look anything like I've seen on TV.
Right.
So I can't vouch for what they're saying. I can vouch for what I'm seeing. I say I can't prove it because I can't show people what's in my telescope. I I don't have a video. It's just a telescope and you look at the stars. So that's pretty much where I would leave
No
it
doubt.
at. So I have a question for you for the globe model.
Okay.
Got a little Earth here.
Right.
Got a little Earth. All right, this is the Earth. Okay, this is the oblate spheroid, in the words of Neil deGrasse Tyson, who was my hero, but he is a croc now. So that's that. You don't even know how disappointed I was in that man. All right, so
That's my dude, by the way.
Neil,
like Neil.
I can't, man. I can't. So all right, so my question is, what is the deepest man has ever dug?
Okay. So the deepest we've ever dug was I want to say a 7 or a 9 inch hole. It went down
Say inch.
the width,
The width. Okay.
but it went down 7.5 miles.
7.5 miles.
So like 40,000 feet, a little over 40,000.
That's fine. Now I want y'all to take into account 7.5 miles. Okay. This is the Earth. The Earth from surface to about midpoint. It's about 3,400. Let's call it 37.5. Just see what happens. So from here to here is about 37.5. Now, you ever seen the cutout of the orange, and you can see the core, and they show you this is what that layer looks like. That's what that layer looks like, right? This is what I call a stretch. You're telling me that you were able to extrapolate 3,000 miles or 3,700 miles from seven miles.
7.5.
7.5. You something else. So you telling me you can extrapolate that much distance from 7.5 miles, and then put it in the book and be like, hey kids, this is correct. I would say that that's a lie, straight up and down, because if I told you, hey yo, I need you to go ahead and land in Jersey, and when we get to Jersey, I'm gonna tell you exactly what California look like. That's 3,000 miles. You would be like, this dude is crazy. So, but when they put it in the book and the official people say it is right, that don't make sense. Like, why are we just completely trusting them to tell us the truth? They could just say, we've been 7 miles deep. Now we're going to teach somebody else to get the rest of the way that we think is down there, instead of showing us an actual model of a cutout and the core to which we've never been.
Right. So we've never gone to the center of the Earth. So the furthest we've ever gone down by digging is 7.5 miles.
Right.
So we also know furthest point we can go down in the ocean. So going from ground level down into the ocean, like we know the deepest point that we found so far is Mariana Trench, and that's about 35,000 miles, or 35,000 feet down, right? So what you're pointing out on the medicine ball, right? It seems like you were talking circumference versus radius. So going straight down 7.5 miles wouldn't be the same as going around 7.5 miles.
I see what you mean. Well, I was talking about radius. I couldn't do it, but I'm here and I'm talking about 7 miles straight down.
Right. So
not around.
So we know the mantle, right? Just the top layer of the Earth is 25 miles deep.
Okay.
So if we only go 7.5 miles down, and we know it's 25 miles deep, then we haven't even cracked all of the surface to get to the next layer.
Now I'm with that. That's what you write in the book, though. You don't write all the other stuff in the book. You write, we're 7.5 miles down into the mantle, and you close the damn book. You see what I'm saying? Like,
Yeah.
that's it.
So how do we know what's in the middle?
Right.
We've seen volcanoes spew stuff out that comes from deeper.
Yeah, it could have came from 15 feet deeper than where you dug.
It could have, but we know under what we dug, that stuff is there. We might not know how deep it is, but we do know it comes up from there.
Right.
And so if we take that into consideration, we can go back and look at layers of rocks and see how, back in the early stages of how Earth formed from volcano activity and molten lava and that kind of stuff, and we see how it hardens and turns into crust, and we can see layers.
Okay.
So in order for me to have this debate, I try to learn both sides, right? So what would you pose as the most, I guess, concise flat Earth.
Okay.
What would that look like?
All right, so basically it would be a petri dish of 66,000 miles in circumference. The middle of it is the North Pole. Works just like a magnet. The middle of a magnet is the North Pole. Every point away from the North Pole is the South Pole. So every point away from the middle is the South Pole, or on the way to the South Pole. The way that you can circumnavigate a flat Earth from east to west is just going around in a circle. They would say that it's like this on a globe, but on a flat pizza, if you just take the median line and you go around in a circle on that median line, it would be how you circumnavigate from east to west. You can't circumnavigate a flat plane, which I believe we live on, north to south, meaning from here all the way down around back to there. That's never been done. And the reason they say it's never been done is because it's too cold or whatever, and that's fine. I mean, we have high altitude planes that fly in much harsher conditions than anything underneath it, because the weather is much less dense up there. So you can just fly at high altitude somewhere up in the, like right underneath the exosphere, and just ride that wave all the way around north to south, live streaming on Instagram, NASA, and show us. That's what you're doing. But they can't do it. I bet I don't got no money though. If I had money, all right, so when I get money, I'm gonna bet money that nobody can do that. It can't be done. It's a safe bet.
So if we show you video of it being done by a NASA,
Then I lost a lot of money that I don't have.
no, we show that now
Oh, circumnavigating north and south?
from space.
Oh, then that's fine. Where's it in? Yeah, we could drop the link in the description. If that's the truth, I'm wrong.
We'll put the link in the description.
Yeah, if that's the truth, I'm 100% wrong. My next question. Oh, and that's a great segue. Why don't airplanes fly to space once they reach the stratosphere? Now, I'm going to explain why this question is relevant, okay? So we're in Raleigh, okay? We come up off the ground, we start flying. When you get in the stratosphere, you know that you just go straight. Everywhere around a spherical globe is somebody else's sky. Everybody has to understand that. So this is outer space. This is outer space. This is outer space, and this is outer space. But anybody who's ever been on an airplane at any point ever, you know that once you get in the stratosphere, you stay there for however long you're gonna be there. So if you're going to Australia, it's 23 hours or 17 hours, however, that's a crazy flight. People grow old on that flight. So however far you're going, you stay straight. Now, everybody knows that any deviation on an airplane, you feel it. You drop down 2 inches, you feel it. Because you're suspended in mid-air, you feel everything. So how does an airplane not account for the curvature in the flight the whole way? You would be flying in a hexagonal pattern because the Earth has a circumference of 24,901 miles. That's a definite determinative number, meaning that at some point you have to account for the curvature of the Earth. That never happens. Why?
You mean why don't we feel it?
Why don't we feel it? I would say, why don't we feel it?
That's an easy question. We've born on Earth, so we don't really feel speed. We feel the change in like acceleration or deceleration.
Mm-hmm.
That's what we feel.
Okay.
So if the Earth is spinning, unless it slows down or speeds up, we won't feel that.
Okay.
So just like on a plane, you feel turbulence.
Okay.
So we can see the clouds moving. Looking at the plane, we see the clouds moving. If we hit a pocket of air that causes any sort of directional change, you feel that.
Right.
Otherwise, it's just like riding in the car. You don't feel the car. If you were to close your eyes, you don't really feel the car moving. You feel the engine humming. You might feel a pothole, but you don't feel the car. You don't look down and be like, oh, I'm going 60 miles per hour.
But I know I'm moving now.
Because you look out the window. So,
But you can feel you're moving.
You feel the engine roaring, and you feel the vibration of the car, or you feel maybe the car shifting a little bit in a lane. But if you were to get on something that just went straight at a steady or at a constant speed, you wouldn't feel it unless there was some sort of change.
Right. I can agree with that.
It's the only thing you would feel the change.
Yeah.
So to answer why, like, the plane flying around the stratosphere going into space, well, one, once you go up high enough, you're going to lose oxygen. You got to consider pressure, radiation, and other kind of things. So like de-icing becomes an issue. So like you have a lot of issues of that plane not being built to go that high.
Okay.
So outer space, in the sense of, I don't know, I guess an astronaut would be outside of the Earth's atmosphere.
Right.
So anything in the atmosphere wouldn't be outer space because it's not out of the atmosphere.
Got you.
Anything in the atmosphere is going to still, everything's still going to happen like you're on Earth. You're just at a higher level.
Okay. Now, one more piece to that,
Okay.
because I agree with the acceleration, deceleration part, but I also know that I've been on like merry-go-rounds and carnival rides. You can feel when you're like moving or not moving, but that speaks to the slowing down and speeding up. The basis of the question was, why won't the plane just go flat outer space? I mean, just, flat out into the stratosphere or further than the stratosphere, and it's making a curved flight around the ball. But the nose should dip at some point. Airplanes are rigid, so they go straight, and that's pretty much it. They don't have a natural curve to how they fly. So why can't we feel the curve and how he fly, but if he drops like 1.5 inches, we can feel that?
So you're saying, why don't we just fly off the Earth?
Right. No, I'm saying I understand why we
go
don't.
into space.
Right. I understand why we don't, because they have to account for the curvature. But why don't we feel that? So what I'm getting at is, we don't feel the account for the curvature because there is no curvature. That's what I'm saying. I'm saying that it's literally how we feel it. You go up, you fly straight, you might turn a little bit, very wide turn, and then you land to where you're supposed to be. And that's it. That's what I'm suggesting.
Right.
So I'm just suggesting that what we feel with our 5 senses is correct. And I think that they're trying to teach us outside of our 5 senses. Like the things that keep us alive, if we were in a flight or fight situation, is the things that I'm going to rely on for my flat earth arguments, because none of Einstein's theories are going to help me in a flight or fight situation.
So we know 80 to 85% of our I guess, feedback or our information comes from visual cues, right? So if you take that into consideration, the easiest way to trick somebody is to change what they're seeing.
Right.
So like a flight simulator can change up, just making you look like you're going through something fast.
Okay.
There's a ride at Frankie's or at Dave & Buster's I hop on with my daughter. She goes through the roller coaster. Okay. The main thing is they put some wind on you. They show you a picture. You're going through it really fast. You feel like you're flying. Okay. So the plane going off the Earth, gravity's going to keep it intact with how the Earth rotates. Okay. And so everything we've done with flying takes that into consideration. Okay. It's just wind velocity and learning how to keep the air under the wings. That's why the wings are shaped the way that they are. So you don't just nose dive into the ground. Gotcha. So I guess it goes back into your round or flat Earth, right? Where you can circumnavigate east to west. Right. Right. So then, if the Earth would be flat, how would a lunar or solar eclipse work?
All right. So the easiest way to explain this is the Earth is flat. It's a flat plane. I'm not sure how well you guys can see this, but I'm gonna try. Okay. So the Earth is a flat plane. Over top of it, now imagine a circle here. Okay. Over top of that flat plane, I'm gonna draw it up. Over top of this flat plane are two electromagnetically levitated spherical balls of independent light. Okay. So this ball of light will be the sun. They flow counterclockwise. They flow clockwise above our head. All right? They have a spiral pattern to it, which gives us our seasons. The further, the closer the sun gets to the North Pole, that's what you would call summer. And the spring equinox, which is coming up pretty soon. The sun is getting closer, so we get more daylight. So it's getting a tighter pattern. That's why you get longer days and you get more heat. As the sun moves further away, you get winter, which is kind of what we're coming out of at some point. The moon and the sun are like the tortoise and the hare. The moon moves at a very steady pace. The sun oscillates up and down, moves like faster, slower. Sometimes they catch up to each other. It will really be the sun catching up to the moon. Sometimes it catches up from behind, which would be like if we're all on this plane, somewhere closer to the middle. Behind would be, for the moon would end up behind, and that would be an eclipse for us, okay? And then on the other side, the moon could be in the front, and that would be the lunar eclipse. So it would be solar eclipse here and the lunar eclipse there. And that's the easiest way I can explain it without going too much and needing more props. That's
No doubt. So we know majority of the time on Earth there's an eclipse somewhere.
I can live with that. I don't know that. I'm
Well,
okay.
the round Earth knows that.
Right,
That
okay.
They believe there's an eclipse on the Earth, usually somewhere.
Got you.
So with that theory and how the flat Earth describes the sun and moon, right? Just going off visual. If we're not circling around the sun, that means the sun is circling around us.
Yes,
So we should see it start smaller and get bigger.
we do. At the beach.
The sun gets bigger.
Yes.
Those are the sunlights.
The who?
The sunlight. So if you we had an eclipse a few months ago.
I had a question about that too, but go ahead.
All right.
I'll ask you.
So we had this eclipse. So we had to put shades on to view the eclipse.
Right.
So when you put the shades on, you see how small the sun looks from our viewpoint.
Right.
Right? So then you realize everything that we see isn't the sun, it's light and it's broken up and scattered in our atmosphere.
Right.
Right? So the sun is actually small. If you watch it go across the sky, it doesn't get bigger and smaller from East Coast to West Coast.
Okay.
Like from North Carolina to California, it's not like we see a small sun and they see a progressively enlarging sun.
Right.
Right?
Yeah.
So if that model was accurate, wouldn't we see something smaller getting bigger until the point where it's big enough and right overhead and then get smaller again?
Yeah, it's not significant enough to make a huge distinction, but because of how our eyes work, we have rods and cones, and everything comes to a point. So kind of like when we are looking down a hallway, it looks like the hallway is getting smaller, a long hallway, but it's not. It's the same size all the way down. So you know that the hallway is not getting smaller, but if you just stood there and you had to draw it or something, it would be converging lines. So the sun being further away, it would come from our eye level because of perspective of where we are. It's still the same height, but it's so far away. It's kind of like if my eyes were right here at this table and you took this pen and moved it away, the pen would look smaller, but it's the same size. And
Right.
as it comes overhead, it's not gonna get any like significantly bigger. It's whatever size it is, and then it goes away. And that's pretty much what we see with the sun and the moon. The sun and the moon are far away on the same plane as us, but it's higher than us. Now, distances and stuff like that, I would guess a couple thousand miles, maybe. Not 93 million miles for the sun and not 278,000 for the moon. Like, I don't know where they get these numbers, but Newton, who is like the father of this whole situation, the Copernican theory and everything, the globe model. His first estimation of the sun was 3 million miles. Where did they get the 90 from? Like, you know how many?
93?
No, it was 3 million miles.
No, you said where did we get the 90?
Yeah, where they throw the extra 90 on. Like,
Well, it fluctuates between 91 and 94.
works for me. Where'd he get the 3?
I don't know where he got the 3.
Bang. And that's the father of the globe models being professed like all over the world. Like, he's the guy.
Right. So with him, with what Newton did was spark the thought. So it doesn't mean he was right. It just means he sparked that thought.
I like to stick on the part where he wasn't right, and then you just go from there. Like, I'm not saying that I know, because I haven't been out of space. I can't say I know. All I know is that water is flat always, and I've never seen, you can't put water on this ball and make it stick. That's not how it works. That's a fact. But I don't even have that on my questions. I'm gonna leave that because we do that all day. But I know that when you look at how this story came about and how it's being dismantled lately with the rise of technology and different people having cameras and all that kind of stuff, I would have to argue that maybe we just need to revisit it and try to staple home what exactly is going on. The ramifications of that seems to be that as soon as you start to ask these questions to established facts, there's a kickback. Oh, you're dumb. You shouldn't be thinking about that. We solved that thousands of years ago. That's not science, though. I thought you keep revisiting it. If it doesn't work, you get rid of it. If it does work, you keep it going and somebody else revisit it. You know what I mean?
Yeah. So the beauty of scientific method, if you can visit something and that hypothesis, you can test it out and it leads to what you thought would happen, right? You kind of make a theory out of it. Now, if somebody else comes back to the same test, or that law or that test holds up over time through everything that you know becomes a theory, right? So that theory ends up being something that you can test, retest, and hold on to.
Okay.
Right? So that's one reason why people don't want to come back to the round Earth, because they already know that it's round.
Okay.
So like, if you even take NASA out of the picture, we just had Elon Musk send a ship up to space. He's an individual. He's not associated with any government, right? He had cameras on his rockets. They showed Earth. They showed the rockets leave. They showed them come back, right? So both of them had cameras on.
Got it.
So we saw it.
Got you.
He put his first Tesla into space. The car had a reflection of the moon on it, or the Earth on it. So we again saw around Earth. We saw the cameras leave and come back. Right, so that's kind of like some more visual cues to kind of back up the same thing, and they have no association with any government.
I would argue that if you can put a rocket in space, you're definitely associated. Like, they're not just gonna there are no-fly zones for a reason. I'm pretty sure space is a no-fly zone.
Space isn't a no-fly zone.
You can't just go to space. First of all, you got to get clearances to blow a rocket off the ground. And whoever you got to get to sign that paperwork knows NASA. Like, so he's affiliated. But I'm cool with him being an independent guy. Great. That's what we need. Independent exploration of space. The rockets going up. I didn't see the videos. I know that they said the rockets went up. I'm good with that. I didn't see it. When I see it, I'll be able to confirm it or deny it. But I can't sit here and say that you're wrong about that. The only thing that I would say is, anytime I've seen a video of Earth from space, in the background, you don't see a single star. But you go to Arizona, you go to Chapel Hill on a clear night, you see all kinds of stars. The reason I think that that's the case is because stars are not around us. They are above us only. So you can go out of space as far as you want, but if you look left to right, just like on an airplane coming back from the Caribbean or something like that, clear night, you can't see stars because they're not on your left or right. They're only above you. Now, if you had a clear drop-top airplane, first of all, it would crash. Secondly, you had a drop-top airplane or a clear top airplane, you'd be able to see that the stars are only above you. And that's because of the flat model, the stars are draped across the horizon. They're just put on top and only on top. That's why like I was saying, you can't see it in the rocket ship. And I'll check his video. If I see stars, hey, great. I mean, maybe I was wrong. But from every single video I've ever seen of somebody going to space, you never see stars. And this is amateur cameras too. Like people who just go up and like, hey, look, the Earth is flat. And I'd be like, well, I wasn't there, so I can't really, I don't know. But maybe. But even in those, you might see the sun, but you don't see any stars. You know what I'm saying? So I think that literally the stars are fixed directly above us, like it says in the flat model.
All right. Well, for time's sake,
Yeah.
I won't go into that one.
Okay.
But you can move to, who asked the last question? Me?
You did, yeah.
Okay, so it's on you now.
All right, which one I want to hit him with? Hit him with the ooh-wop. All right, here we go. So with a circumference of 24,901 miles, all right, what is the exact distance, either vertical or horizontal, one needs to be to see the curvature of the Earth? I guess we kind of touched on that a little bit.
All right. So you would technically have to go to outer space to see the curvature of the Earth. Okay. Outer space being outside of the atmosphere.
Okay.
Here's why. So whatever plane you're on, right? We believe in clouds.
Gotcha.
Right. So if we leave Earth, if we're looking out on Earth, everything we see is going to be flat, no matter where we go, because it's our viewpoint. If I took an apple, slice the top of the apple off, it's going to look flat. Doesn't mean that the apple's flat, right? In the center of where we are, that slice is our viewpoint at all times.
Now, only problem I have with that is the terminal distance. 24,901 yields to an equation. You can put that in an equation, and then that equation in spherical geometry, it is 8 inches per mile squared of perspective drop on that curve. So at what point does that perspective drop? Like at what point can I stand at the beach and see a boat go over the edge? Like how many miles away? You know what I'm saying?
You see a boat go past the horizon?
Yeah, like over the edge. Like meaning it's so far away that it's down over the curve and on its way back around to me.
Right. So two things. One, every time we go up a level, everything we see, we flown in planes, it looks flat, right? So we still have to keep in mind, we're looking at clouds that are intact with Earth's atmosphere.
Gotcha.
So those
from that perspective,
those are gonna look flat as well.
Okay.
Because we just took that perspective and moved up a little bit.
Gotcha.
Right? So as far as the horizon goes and seeing the boat go over the edge, I don't know the exact distance of how far a boat has to go straight out in order for us to see it disappear completely. But we do know we can see a double sunset, right? Meaning,
start at the ground and go to the top.
yeah, you lay flat on your back on the beach,
Right.
and this is no scientific equipment needed. Lay flat on the beach on your back, right? Watch the sunset. As soon as you see the last piece go over the horizon, sit up or stand up. See if you see the sun again.
Yeah, see the sun again.
Right? That's indicative of curvature.
Okay. Now I would argue
That's an easy.
I would argue, and this is the crazy part because it makes sense in both models. I would argue that the sun is just getting further away from where you are. So the higher you stand, the more you can see. You know what I mean?
I know what you mean.
And that's all I'm saying.
Because up and down wouldn't dictate if you could see further out.
Yeah,
It
that's
dictates
tough.
if you can see over a curvature.
Now I'm gonna have to argue with you with that one because all right, this is a ball at your level, right? Your eye level. Your eyes are not fit to see over a curve. You see what I'm saying? Now the curve we're talking about is way longer, so
Right.
it's a lot different. But your eyes aren't fit to see over a curve. Your eyes are fit to see flat over the plane. So as I get higher up, it would just fall further and further over the curve, and it would be a straight line of declination that I wouldn't be able to see beyond at some point. But if you go to like Dubai, you can, on every floor, every 10 floors or something like that, the sun is set, and then you go up. People do it on Instagram all the time. They go up a couple flights, they see it again, they go up a couple flights and see it again. They do this for like 80, 90 flights. So
is the sun getting smaller or is it disappearing? Because one indicates moving away. One indicates going over a curve.
Oh, it's getting smaller as it goes away. Just getting smaller. Like, not significant. It's not significant.
No doubt.
Just getting smaller.
All right. So, in your model, what keeps the sun and the moon afloat, and what makes them move in the path they're moving in?
All right.
What force is acting on those?
All right, so what set it in motion? Man, listen. You got me. Yeah, that's the ooh-wop right there. You got me, because I have no idea. But Nikola Tesla said, if you look at the Earth, this realm, as electricity and magnetism, it will answer every question that you have about anything. And I started to try to take that approach. So, like I said before, they're kind of magleved above the plane, how the sun and the earth is. I mean, the sun and the moon is. And I don't know how it moves. No idea, but it's definitely perpetual motion, which is something that you can experiment on your own. Maglev something, you push it, and it just goes on forever. It would be, now I'm going to say forever, but it's not really forever, because eventually the molecules from the air slows it down. But if there were no molecules, it would probably, magnetism still works without molecules.
So wouldn't that work against your theory?
What do you mean?
The air molecules would eventually slow it down.
That's what I'm saying. That's what I'm saying. What keeps it moving? Like, that's where the divine piece come in. I'd be like, I could say God's doing it, but that's a cop out. So I would just leave it. I don't know. I have no idea with that one. But I know that it lends to, in the flat model, you don't need gravity. You just need buoyancy and density. Density being that if you have more molecules in you than the stuff around you, you'll fall. If you have less molecules than the things around you, you'll rise. Period. That's why gravity holds tons and tons of water to the ground, but it can't hold a gnat to the ground. Because are gnats stronger than gravity? Are they in the gym? They entitled? Getting this money? No, gnats ain't strong. What they do is they're just lighter than the air, and they can manipulate it. They're not lighter than the air intrinsically because they land, obviously because they're heavier than the air, but they can use their wings to be lighter than the air. So when they are lighter than the air, when they're using their wings in manipulation, gravity plays no part. The only reason that they land is because it's time to land. Like,
So here's the flaw in that model.
hit me.
Right? So if what you just said is true, then how would we get an airplane off the ground?
Glad you asked that. So at a certain speed, you ever take your hand and put it out the window? Feel like you're moving through water, right? So air and water are exactly the same. One's more dense than the other. As you get, like, we're at the base level, we're at water. You rise, the higher you get lighter and lighter. It's just water, but it's air. Let me take that back. Because that lady like, this boy sick. Water is not air. Okay. It's just a dense compilation of molecules together. As you get higher, it gets thinner.
Right.
That's it. That's the difference between air and land. Air is the mass, like, congregation of molecules, and then, land is the mass congregation of molecules, and then as you get higher, you get lighter. So you can manipulate it by putting aluminum foil in the air, using a propelling jet and the propelling engine, and pushing through the water, as you would, like a jet ski, but in the air, controlled by drag and lift as you manipulate through the sky.
Without falling.
Without falling. The reason you do it is propulsion, like the constant motion. Because if you stop, you cut the jets off, then you fall. Because you're heavier than air.
Okay.
And that's it.
So who just asked the last question? You or me?
I'm gonna go with me. Yeah.
All right. So if what you just said is true, right? Mm-hmm. Why wouldn't we just, I'm gonna stick to what I had.
All right, go ahead.
This on the paper. Actually, that is on the paper. Why has no one traveled to the other side of, if we can fly, right? We can go straight out, right? Why haven't we been able to make it to the other side of the earth or over the boundaries of the wall?
The Antarctic Treaty, I believe, is the reason why we can't go there. I don't know anybody with an airplane, but I just know people say, they could be lying, I don't know. But people say that they have airplanes. They try to, like, from South America, they try to fly over the edge and they're turned back by military. They have an Antarctic treaty, I think it's standing since like 1956. It's like 50 countries saying that basically you can't just freely go here. You can come under our guidance, but you can't just freely be in Antarctica. Like you can't just get on a boat in South America, go like 700 miles, climb the wall, and then start walking.
Right.
It's illegal for whatever reason. I think it has something to do with because it shows the true nature of the shape of the earth of where we are.
Now, we know we can't go to France without proper documentation and just get off the plane and go out.
Right.
And that's just over the water.
That's proper documentation.
Right.
Once you get it, there is no proper documentation to go to Antarctica alone freely.
So we'll put that in the link because you just need a permit to go to Antarctica. I've known.
And you can go by yourself.
Yep. I know 2 people.
You know 2 people that went to Antarctica.
2 people.
Cool. I need.
We'll put that in
Get
the link.
them.
As a matter of fact,
Get me with them.
About 2 days ago on my Facebook page.
Yeah.
Right. We had this debate. And
Yeah.
You got up there, right?
Yep.
And I posted pictures of one of the people that went there.
Good. And they around. They local?
Yeah.
My man. I need to meet him because I got questions. All right. So I can table that. I'm going to say that if that guy actually went to Antarctica freely,
That was a girl.
if that woman went to Antarctica freely, then everything that I just said is wrong. If that's what happened. If that's what happened. So we'll see. So next question. I definitely did ask a question before that. Okay. So why are the Challenger astronauts still alive? And this is something that people can Google on their own. The Challenger mission blew up, or the Challenger rocket blew up in 1984? 88. So all of those people are still alive. I actually called 2 of them, one lady that works at NYU and one lady that works at Syracuse. They're both professors of law. And the pictures look exactly the same. I don't have anything here. It would take a laptop for me to show you the information. So I would just say Google the Challenger explosion and Google the people that were supposed to have died in there. Google their names and then you'll see where they worked at and all that kind of stuff. And then you can call them like, yo, why you still alive? You died in 88. You see what I'm saying?
Interestingly enough, I did just that. So
Get out of here.
I Googled that.
Good.
Right? So several things came to mind. One, they did have people that looked just like those astronauts.
Okay.
That had the same name.
Right, there you go.
That were aged about the same as they would have been aged had they stayed alive.
Right.
Right?
That's a lot of what's the word?
Coincidences.
Coincidence.
So,
say that again.
Coincidences.
Coincidences.
Say it again.
Sometimes you mess it up.
So now 2 things came to mind. One, we did recover bodies.
Okay.
Right? So they didn't die from the actual spaceship falling apart.
Okay.
They died from the impact back into the water.
Got it.
Right? So that aside, I can Google, I guarantee you I can look up right now a Heath Ledger doppelganger and pull that person up.
Okay.
And we will be like, oh, I thought you died.
Right.
So because they still look like they exist doesn't mean it's that person. One being, why would NASA go through the trouble of airing that, having the funeral, the services, and all this other stuff, and then put these people in a public spot? Like one guy's like the CEO of, I forgot which company. He's the CEO of a company.
Right.
You said
That's the guy, Dick something, Richard
I
something.
think so.
Yeah.
And you said
Scobie.
one person was working at NYU.
Right.
Like these are very, like those are like out there.
Yeah.
So it's not like they're trying to hide them.
Right.
So why do something that, I guess, devious and not even try to cover it up?
I want to go back to something as simple as they told you that milk was good for you. Mm-hmm. That's why. Because they feel like they can. And that's number one. Number two is, here's what they definitely didn't count on. Nobody counted on the internet being what it is. The internet just took on its own life. Like, there's nothing you can do to stop it now. Like, if people tried to shut down the internet, it would be like some geek that built a server at a storage facility and we have internet again. So they're dead on that piece. There's nothing you can do to stop the internet. I think that overall, the reason why it benefits them to lie in those situations is because, one, they know that people are stupid. A person is smart, but people as a collective are stupid. And it's easier to hide something in plain sight because you ask questions about established facts and the group think automatically ostracizes you. So it's a self-correcting issue. Like, it's like me saying the earth is flat. People will be laughing and stuff like that, but then I ask them something like, well, what's the circumference of the earth? They don't know. So you don't even know your own story, the one that I completely understand, that I chose to go on the other side of because I got new information, but you're gonna laugh at me because I went to the other side. It doesn't make sense. So I think that's why they can bank on that.
So again, going back to what is there to gain, like the why, right? We know off your milk analogy, we know dairy product has money to gain off of people drinking milk.
Right.
Dairy farmers, the whole thing. I'm not sure what NASA would gain by lying about that one space flight blowing up. Now we've sent many others, the stories they've sent many up, right? And I can believe in that conspiracy if it happened or if it didn't happen.
Right.
I think it did happen, but regardless, I can believe in them lying about that.
Right.
But why make that particular one blow up? Two, why wait 30 years to say that they're alive?
Yeah, great questions. I think that the only problem with the question is you put the Challenger situation in a box like it's by itself. I would argue that everything that they've ever done has been a sham. The reason why is to create public trust so that they are the monopoly of the situation. If you want to be a scientist or an astronaut, you have to go through NASA. It's kind of like what the NCAA did to football. If you want to be paid to play football, you have to go through the NCAA. So you see the stuff that the NCAA does, not trying to draw a comparison, but you see the stuff that they do for their gains. It's easier to understand because it's ground level stuff. It may be something that that NASA knows about how human beings work to make them feel like this is what needs to be done. That's the best that I got for that. All right, that's going to be it for this evening. Really appreciate you checking us out. If you have any more questions or if you have any content you think we should go over, feel free to hit us up. Our Instagram and Facebook is.
You can reach me on Instagram at I am Nate Williams or just on Facebook, Nate Williams.
You can reach me at The Freak on Instagram. That is DAPHREAK. And on Facebook, just Instagram, that'll work. So, but yeah, if you like what was going on tonight, let us know because we're probably wrong, but maybe not. Signing out.